Well, good day. Second lesson of the week for Add Math, and let's start by factorizing special quadratic expressions. Start with number 1. Put this here, color. And these special quadratics are going to be solved in approximately 2 to 3 lines most of the time. So for example, this one I'm going to identify the factors of negative 15. So negative 15 has factors 1 by 15, 3 by 5, and that's it. And we're looking for the one that gives me positive 2, so I know a negative 5 adding to a positive 3 will give me a negative 2. So I'm just going to say, okay, well, this is x minus 5 and x plus 3, and that's the answer. Let's go to the second one. Second one is this here. Factorize this, Control C, Control V, number 2. So with respect to number 2, I'm going to be doing the exact same thing. All right, list the factors of 36, which is this factor, this number over here. So I'm listing the factors of 36. 1 by 36, 2 by 18, and 3 by 12, and 4 by 9. And this here will give me 13 if I decide to say minus 9 minus 4, and that'll give me minus 13. So my answer here would be x minus 9 into x minus 4. That's that. Let's go on to the next one. All right, number 3. Control C, Control V, put this down here. All right, so first thing I want to do is I want to factor out the negative sign. So negative of x squared minus 9x plus 18. And then I'm going to write the factors of 18, which 1 times 18, 2 times 9, 3 times 6. And if I take a negative 6 and I add it to a negative 3, I'll get negative 9. And negative 6 multiplied by negative 3 is going to give me a negative 9, a positive 18. So I'm just going to have here, open bracket, and I'm going to have, so remember this is a negative 6, negative 3. So I'm going to have here x minus 6 and x minus 3, and I'm going to have the negative sign out in front here. Now, I can get that negative sign removed, and I don't need to put this line. I can just simply go straight away, take whichever one is negative, and I can just simply do something like this. So I can take the negative sign, multiply it out, and I will get something like this. I will get minus x plus 6. So I can simply say plus 6 minus x, and then I'll have x minus 3. So I can skip this line if I wish to, right? And I can just jump straight from here to here. So notice what ended up happening. The x became negative, and one of the negative terms became positive, and we just switched around, all right? Now let's go to the fourth one now. The fourth one is this here. All right, Control C. Right, so let's see. Negative sign again. So again, all I'm going to do is I'm going to take out the negative sign. This is going to be x squared plus 2x and then negative 15 at the end here. I'm going to try and find the factors of negative 15. Factors of negative 15, 1 times 15, 3 times 5. And I am going to say if I take a negative 5 and I plus 3, I will get a, sorry, that's not right. If I take a positive 5 and a minus 3, I will get a positive 2. All right, so those are my factors. But because I have a negative sign here, I'm going to switch this here. All right, I'm going to switch this here. So I'm going to say something like open bracket, close bracket, open bracket, close bracket. I'm going to say 3 minus x, and then I'm going to say x plus 5. All right, so I usually just take the one with the negative, and I just use that one most of the time. Okay, let's go to the next one, which is number 5. So number 5. All right, for this one, right away, I'm looking at this number and I'm thinking to myself, that's a square value. 7 squared is equal to 49. All right, and I also notice that I have x squared can be written as x to the power of 2. So let me just rewrite this as well. So this is 7. So let me just write this. So 49 is equal to 7 to the power of 2. Right? So now I just need to see if it is that when I do the division of the middle term, so negative 14x divided by 7x, if I get 2 at the end, that's what I have. So let's see. So this here is a negative 2. So that negative sign tells me that I'm going to have to write something like this. X minus 7 squared. And that's the answer. All right, number 6. Let's say we take this one here and put it over here. All right, so again, we want to identify, I identify this here as a number that's a square, right? So 25 is the same as 5 to the second power. So can I write 4x squared as something to the second power? Yes, I can write it as 2x to the second power. Now, all I have to do is I take the positive 20x and I divide it by the 5 into 2x and see what remains. If I get 2, that's great. So x here, 2 into this is 10, and then 5 into this is 2. So I get a positive 2 at the end of it. That's great. So that means I'm using a positive sign in between the 5 and the 2x. So I'm going to say here 2x into positive 5 whole squared. All right, let's go to the next one, which is number 7. Right, so I identify that 81 is a square, which is 9 squared, and 49x squared is also a square, which is 7x. So I'm just going to write here 7x plus 9 and 7x minus 9, difference of two squares, right? And we're going to see here that 4x squared can be written as 2x squared, and then 9y squared can be written as 3y squared. So we're going to have here 3y plus, we're going to have 2x plus 3y, and we're going to have 2x minus 3y. All right, and that is that. Now, I almost made an error there by switching the positions of these two. If you notice, if I did that and I switched the positions, this here would not multiply to give me a negative 9y squared. All right, it would not have given me a negative 9y squared. What I would have had is something like this. I would have had 3y plus 2x, and then I would have had 3y minus 2x. That would have been entirely wrong, because if I take this and I multiply by this, I'm going to get negative 4x, which I don't have, and I'm going to have a positive 9y squared, which is I don't have. All right, so don't make the mistake of mixing them up. All right, let's go on to the next section, which is addition and subtraction of rational expressions. Okay, so this should not take long as well. I am just going to go through it as quickly as possible, because after all, it's just a simple matter of using the knowledge from polynomials and fractions. So for example, this one here, we're looking at the LCM. The LCM is just simply x, and this here would mean 4 plus 3, which is 7 over x. And then we go to number 2. Number 2 is this one here. All right, number 2 is this one here, and let me just erase this. Right, and then work on that. So this here would be two factors I have here. So the HCF, actually I shouldn't say HCF, I should say LCM, right, or lowest common denominator actually, is going to be equal to x minus 3 and x plus 3. All right, so I'm going to write here as x minus 3 and x plus 3. And what I'm going to do is I'm going to multiply the denominator so that it will look like this lowest common divisor. So I'm going to have to multiply it by x plus 3. And this one I'm going to have to multiply by x minus 3. And because I'm multiplying the denominator, I'm going to have to multiply the numerator as well. So it is x plus 3. And this one here is x minus 3. So I'm going to have here 2 into x plus 3. And then put back the operator that I have here. And this is 1 into x minus 3. And then I simplify and cancel where necessary. So using distributive law, I'm going to expand these two here. And using distributive law, I'm going to expand this as well. So I'm going to have here 2x plus 6 minus x plus 3. And notice I'm not even bothering to write out those signs anymore. I'm literally doing them mentally now. So you can start working with them mentally by now. And then you have x minus 3 into x plus 3. And we're going to get x plus 9 over x minus 3 into x plus 3. So that's our answer. Let's go on for number 3. Number 3 is this one here. All right, now remember the first thing you need to do is factorize all your denominators so you can get your lowest common denominator. So our x squared minus 9 is factorized into, or equivalent to saying x plus 3 into x minus 3. That is mentally done as well, right? And then we have, well, x plus 3. So we are seeing that the lowest common denominator is going to be x plus 3 into x minus 3. So we're going to write that out. So x plus 3 into x minus 3. And then what I'm going to do is I'm going to just simply rewrite the numerator. So the numerator does not need to multiply by anything, because quite frankly, this is x plus 3, x minus 3. And this one here is going to need to multiply by x minus 3. So that means I have to multiply here by x minus 3 as well. So I'm going to get x plus 2 into x minus 3. And then I have to expand and simplify. So I'm going to have x. This here with the distributive law is going to give me positive 2x minus 6, all divided by x plus 3 into x minus 3. And we will go about writing this as, what is this, 3x minus 6 over x plus 3 into x minus 3. I can try and factorize the top and get 3 into x minus 2, and then x plus 3 into x minus 3. And if this here on top was a x minus 3, I can just simply cancel these two, right? But it's not, so I can't do that. This is the lowest, this is the simplest answer you can have for this. Let's go on to another one, which is number 4. Oh, this is a long one. Control and C. Add a new page. And then put this here. Then this one here. All right, so again, we factorize first. All right, so x squared minus 4x plus 4. Now, remember, this here is looking like a perfect square. It is looking like x minus 2 all squared. Right? So when we look at the lowest common divisor, we're looking at 1x minus 2 in common to both of them, x minus 2 in common to both of them. And we're also having another x minus 2 that remains over. So this x minus 2 squared is going to actually be the lowest common denominator. So I just put my x minus 2 into x minus 2. I can write it like that, or I can write it another way if I choose to. Anyway, so this here does not need to multiply by anything because this here is already x minus 2 squared. This here needs to multiply by another x minus 2, so I'm going to multiply here by x minus 2 as well. And then we're going to write this out, and we're going to get 3 minus 2 into x minus 2. We're going to simplify by expanding this with distributive law. Let me just write that a little bit better. So this here with distributive law, and we'll get 3 minus 2x plus 4 all over x minus 2, x minus 2. And we're going to have 7 minus 2x all over x minus 2 squared. All right, and that's the answer for this one. Let's go on to number 5 now, which is the last one. And we have here last one, number 5. All right, and let's look at it. So we're going to have here x squared minus 5x plus 6. And I'm trying to see if that is a perfect square, and this here is not a square, so I can't really say it's a perfect square. Let's see if we can factorize. Yes, we can factorize this. All right, so we're saying x here, and then we look at the factor of 6 to give me negative 5. So I'm seeing if I have a negative 2 and a negative 3, I can add them to get a negative 5. Negative 2, negative 3, add them to get negative 5. And let's look at x squared minus x minus 6. Again, I can rewrite that here as x, and then I'm looking for something that multiplies to give negative 6 with a adding to give negative 1. So negative 6 has negative 2, negative 3, positive 2. And when I add those together, I will get negative 1. So negative 3, positive 2. And that's my factors. So my lowest common denominator is going to take whatever is in common, which is the x minus 3, and whatever factors remain, which is the x minus 2 and the x plus 2. So that means we're going to have a very long one here. So this one here is going to be x minus 3 into x minus 2 into x plus 2. And then x squared minus 5x plus 6 is x minus 2, x minus 3. So I need to multiply by x plus 2. So I need to multiply here by x plus 2 to get the denominator. So that means I'm doing the same thing on the bottom here. And that will leave me with 2x into x plus 2. Let's look at the other one. The other one is x minus 3 and x plus 2. So that means I need to multiply by x minus 2. So I'm going to have here multiplying by x minus 2, and I'm going to have here multiplying by x minus 2 as well. So let's work that out. That is plus because of the operator here, and it's going to be x plus 2. And I just need to expand and simplify. So I expand this with distributive law. I can expand this as well with distributive law because this is understood as a positive 1 in front of here. So we're looking at 2x squared plus 4x plus x plus 2 all over x minus 3, x minus 2, and x plus 2. When we finish this, we're going to get 2x squared plus 5x plus 2 all over x minus 3, x minus 2, and x plus 2. Now, all I have to do is figure out whether or not the top can factorize. Let's check and see. So 2x squared plus 5x plus 2, and if it can factorize, let's see. We can see 2 by 2 is going to give me 4, and 1 times 4, positive 1, positive 4 multiplying by each other can add up to give me positive 5. So yeah, we can say 2x squared plus x plus 4x plus 2 factorized by grouping. And we can see x into 2x plus 1, and we can see plus 2 into 2x plus 1. So we have here 2x plus 1 and x plus 2. So right on top, we're going to have 2x plus 1, x plus 2, and then we're dividing that by x minus 3 into x minus 2 into x plus 2. So this can cancel off with this, and we'll remain with 2x plus 1 all over x minus 3 and x minus 2. And that's the answer, the final answer. All right, let's go on to the next section now, which is multiplying and dividing rational expressions. This here is simple. Multiply top by top, bottom by bottom if you have multiplication sign. And if you have a division sign, you rewrite, and then you do the same thing that you do for multiplication. So let's do them quickly now. So here, all right, so this here would be equivalent to, 5 2s are 10, x squared, and that's the answer. All right, let's just do this one here. right? This one here would be written as x plus 3 into x minus 3, and dividing that by x squared minus 9 into x plus 3. All right. We can just simply cancel these here, the common factors, and then we will end up with this, and I can factorize the denominator. I can end up with this x minus 3 divided by the denominator of x plus 3 into x minus 3, and then this here will cancel with this, and I will be able to get 1 over x plus 3. That's the answer. Let's go to number 3. Multiplication and division is much faster than addition and subtraction. All right, so let's see. We need to rewrite this, right? We need to rewrite this. So I'm going to have here x squared minus 4. You know what? Let me write it out. No, I'll rewrite first. So let's see. X squared minus x minus 6. Multiply and then invert. So x plus 2 on top now. And then, so I switch these in essence. X minus 2. So that's when I change it to multiplication. All right. Now let's factorize this here. So I'm seeing x squared minus 4 can be written as x plus 2 and x minus 2. I'm seeing that x squared minus x minus 6 can be rewritten as open bracket x, and let's say we need a negative 3 and a positive 2 to achieve that. And we're going to have here, rewrite the top, so I'm going to have x plus 2, x minus 2, then I'm multiplying again, so it's x plus 2, and then I'm writing the factors on the bottom. So this here replace with x minus 3, x plus 2, and then I rewrite this at the bottom here too, so x minus 2. So let's see if we can cancel off a few things. Here I can cancel it here I can cancel it here, and what I would remain with is x plus 2 over x minus 3. All right, let's go to number 4. Number 4 is here. So number 4, we have, let's factorize the top and the bottom because it's already in multiplication form. So x squared minus 9 can be rewritten as x minus 3 and x plus 3. And then we have x squared minus 4x plus 4, and that can be rewritten as, let's see if that can even factorize, x into x, and then we're looking at a positive 2. Oh, this is perfect square. This is a perfect square. So this here is x minus 2 all squared. And let's see what else. We have x squared minus 2x can be factorized into x into x minus 2. And then the last one, which is x squared minus 3x minus 10, can also be factorized, I believe. So let me just set this up here as x and x. I can see a negative 5 and a positive 2 can multiply to give me negative 10. So negative 5 and a positive 2 can multiply to give me negative 10. And if I add them up, I'll get negative 3. So I get all the factors already. Let me rewrite everything now. So I have this as x minus 3 and x plus 3. All right, that's the first one. And then next one, I have this as x minus 2 all squared. Nice. Now I'm multiplying that by x into x minus 2 right there for this one. And then we have the last one underneath here would be x squared minus 3x minus, oh, sorry, I did that wrong. I'm supposed to write the factors, which is the x minus 5 and the x plus 2. All right, let's see if we can cancel now. One of the x minus 2 could cancel with one of the x minus 2 over here. I don't see anything else. All right, I don't see anything else. So that means I'm going to have here on the top x minus 3, x plus 3, then I have x, then I have x minus 2, x plus 2, and then I have x minus 5, and that's the answer. All right, nothing else can cancel. Okay, that's that. Let's go to number 5. Yeah, 5 is the last one. Go to the last one here. All right, so let's rewrite first. So I'm going to have here x squared minus 4x plus 3 divided by x squared minus 9 multiplied by x minus 1 over x minus 3. I just simply switch these here. And then I factorize the x squared minus 4x plus 3. And I'm looking at possibly writing x, write that over, x into x. And we can see 1 and 3. And I can say negative 3, negative 1. If I multiply those two, I get positive 3. If I add those two, I get negative 4. So that works. And then I have x squared minus 9. I can rewrite that as x plus 3, x minus 3. And let's rewrite everything now. So I'm going to have this here is going to be replaced with this over here. So I'm going to have here x minus 1 into x minus 3. This here is going to be replaced with this here. So I'm going to have on the underneath x plus 3 and then x minus 3. And then I'm going to multiply on the top by another x minus 1 and then another x minus 3. All right, so one of these could cancel here. And now I have two of those, and then that's one of those. So I'm literally going to get something like this: x plus 1, x minus 1 over x plus 3, and then x minus 3, and that's your answer. All right? Okay, so that's that. I think that was the last one. Yeah, that was the last one. Let's go on to the next lesson now, which is remainder theorem. Okay, so this one here is going to take a little bit longer because this is 5 questions. Wow. Okay. I think I really overdo it on these problems questions, right? And then B. Right. So the first one is here. Right. So we're required to find the remainder when that is divided by that. All right, let's solve this. So if x minus 3 is the divisor, then a is equal to 3. And we only obtain that by just simply solving this. X minus 3 equal to 0, which implies that x is equal to 3. And we're just saying a in this case because our rule is then by applying the remainder theorem, P of a equal to r, we get P of a, or P of 3 would be equal to, what is it? So it's 3 to the third power minus 4 into 3 to the second power plus 3 plus 6. And I will try to do this mentally. 3 3 is 9, 3 is 27. 9 by 4 is 36 plus 3 plus 6. All right, so if I decide that I add these two together here, I'm going to get 30, and then I add this, it's going to give me 36. So 36 minus 36 is 0. So the remainder is 0. Given that that leaves a remainder of 7 when divided by this, given that that leaves a remainder when find the value of m. Okay, so I need to find, and then just copy the whole thing. So find the value of m. All right, so that means I'm going to say if x minus 2 is the divisor, then a would be equal to 2. And since the remainder is 7, then by applying the remainder theorem, we get, what do we get? Oopsie, this thing is in, let me just add a page here. This thing is in white, it's in green. Let me just select this and write it in yellow or white. I'll put white. All right, so if that's the case, then we will get something like, P evaluated at 2 would be equal to 7, right? So P of 2 would be equivalent to what? So that is 2 squared, 2 into 2 squared, minus mx, sorry, plus mx, and then minus 5. So I'm replacing this x with a 2, and then minus 5. All right, and that would mean we have 2 into 4 plus, well, I should just put that as 8, and then this is 2m, and then minus 5. And this here simplifies to 3 plus 2m. So this is equal to 7. So P of 2, which is equal to 3 plus 2m, is equal also to 7. So what is happening to my m? My m here is multiplying by 2, and I'm adding 3. So I'm going to have to reverse the operations in this direction. So I say minus 3, and then I divide by 2. Or I can say something like multiply by a half. All right, so let's work on that. We can see here right away, if I do the first thing, which is the minus 3 from both sides, I'm going to get 3, I'm going to get 3, and then minus 3 from both sides, and then plus 2m is equal to 7, and then minus 3 here again, right? And then from that, what we can see is we're going to get something like 2m is equal to 4. And then I can divide by 2 both sides, right? So I'm dividing by 2 on both sides. And I can see right away that this here cancels with this to leave me with 1m, and this here cancels with this to leave me with 2. So this m is equal to 2, right? So therefore, m is equal to 2. And that's the answer for this one. Let's look at the another one, sorry, not the another one. So this is the other one here. Right, maybe put it in green. and then I'll write in white or yellow. All right, so if this leaves a remainder of 0 when divided by this, determine the value of n. Okay, so that means if x plus 3 is the divisor, then a is equal to minus 3. By applying the remainder theorem, we know that p evaluated at negative 3 would be equal to 0. P of negative 3 is going to be equal to negative 3 raised to the third power plus 3 into negative 3 squared plus n into negative 3 plus 9. And this here is supposed to be equal to 0. From there, we can just simply start working with this section of it so we can find n. And that is negative 27. And that is positive 27. So this here works out to be 0. And then here we have negative 3n plus 9 equals 0. So just have this piece here remaining. What is being done to my n? Let me see what's being done to my n. My n is simply multiplying by negative 3, and then it's adding to 9. Remember, you follow BODMAS to do the order of the operations. So reversing this would be negative 9, and then we'll have to divide by negative 3. So let's see what we get here. From the time I take both sides and I minus 9 from both sides, this 9 here will disappear, and I will remain with negative 3n, and I'll know that 0 minus 9 is going to be equal to 9. Negative 9, sorry. And then I divide both sides by negative 3. That means n would be equivalent to negative 9 divided by negative 3, which is just going to give me an answer of 3. Right? So therefore, n is equal to 3. All right? All right, here's number 4. We're required to determine the remainder when this is divided by that. Okay, so if x plus 2, sorry, a half, is the divisor, then a would be equal to negative a half. Applying the remainder theorem, we can get that p of negative a half would be equivalent to 4 into negative a half squared minus a half, negative a half, sorry, plus 2. And we will get that this is a quarter multiplied by 4 is just going to give me 1. And then this here is negative and a positive, which will give me positive a half. And then this is plus 2, so I'm going to get 3.5. All right, so therefore, the remainder is 3.5. This one says find the value of k such that this leaves a remainder of 4 when divided by, this is by, I didn't select the whole thing. So divided by this. Okay, so if x minus 2 is the divisor, then a would be equal to 2, right? Applying the remainder theorem, we get, by applying the remainder theorem, we would get that p of 2 would be equal to 4. So p of 2, actually, you know what? P of 2, which is equivalent to 2 to the second power plus k into 2 plus 1 is going to be equal to 4. Working with this section here now, and I can see that 4 plus 2k plus 1 is equal to 4. 2k plus 5 is equal to 4. I'm going to minus 5 from both sides. I already mentally did all of this here. So it's multiplying by 2, adding 5. So I already did that mentally, and I'm going to reverse my orders operations now. So I'm minusing 5 both sides. I'm going to get that 2k is equal to minus 1. And then I'm dividing by 2 both sides. I'm going to get k is equal to negative of a half. And that's the answer. So therefore, the remainder is negative a half. So therefore, the remainder is minus a half. All right, let's see. That was number 5. Let's go on to the next section now. And this is the final section, which is factor theorem. All right. Factor theorem, and we have 3 questions. Oh yeah, lovely. I was nice to myself this time around. All right, let's see. So we'll do this one here first. All right, Control C, Control V. Here, green, pencil, white. All right, so determine whether this is a factor of this. If x plus 2 is a factor of p of x, then p evaluated at negative 2 would be equal to 0. P of negative 2 would be equivalent to negative 2 raised to the third power plus negative 2 raised to the second power minus 4 raised to negative 2 and then minus 4. Right? And then we'll solve that, sorry, would be equal to 0. So we're checking that right now. P of 2 So P of 2 is equal to this, and then 2 2s of 4, 2 is a negative 8, 2 2s of 4, so that's positive 4, and then negative 8 again, and then negative 4, and you can see right away, this is positive, so this cancels with this, and this cancels with this, and we get 0. Therefore, x plus 2 is a factor of P of x. All right, so we're required to find all linear factors. Now remember what we have to do. We have to list the factors for the coefficient, list the factors of this coefficient and this coefficient. The factors of 6, 1 times 6, 2 times 3. And if we look at 2, 2 has the same factors of 2 has the factors of 1 times 2, which is it. All right, so we can see that this isn't common here, so we only have to check positive 1, negative 1, positive 1, negative 2, sorry, positive 2, negative 2, positive 3, negative 3, and positive 6, negative 6. Right, those are the only factors that we have to check. We'll start off with positive 1 first. Now remember, as I said, I don't like to do all of this here. I like to do this on my calculator. So here's my calculator, and let me just first put in the equation. So 2 recall twice. If I press recall twice, I'll get that x, and then I'm going to have that raised to the third power, and then put my cursor down here, plus x raised to the second power. Then I have negative 13x, and then I have plus 6, and then I'm going to press equal. I'm going to get 6 because I have 0 stored on x. But what I need to check is the 1, the 2, the 3, and the 6. So I'm going to store 1 on x and check my formula again. And I get negative 4. I'm going to store negative 1 on x. I'm going to check my formula again. And I'm going to get 18. All right, let's go to 2. So I'm going to take 2 and store it on x and check my formula again. I get 0. Okay, so positive 2 works. All right, positive 2 works. Let me check negative 2 one time. So I don't have to come back here. And then I would store that on x. Check it over here, and we get 20. So negative 2 does not work. Let me just recall and make sure that, yes, x is negative 2. All right, great. Let's check next. Positive 3, negative 3. So 3 stored on that. Go back and check it, and we get 30. Negative 3 stored, and go back and check it. We get 0. So negative 3. So I can see that positive 2 and negative 3 are factors. So next one we're going to check is positive 6. Positive 6, check that. Oh, no, negative 6, x, and we get, oh, all right, so I know that positive 2 and negative 3 are my factors, or my a values. So I can say when x is equal to 2, then that means this here would give me 0. And I can just simply test that. So I can say q of x, q of 2 is equal to 2 into 2 raised to the third power plus 2 squared minus 13 into 2 plus 6, and we will get 2 2s 4 2s 8, 2 16, 2 2s 4, and this is 26, and this is plus 6. So this here is 20, this here is 6, this here is equal to 0. All right, so then that means my divisor for this, then x minus 2 is a factor of q of x. All right. Now we can use synthetic division to solve the problem. So using synthetic division, we can reduce it with synthetic division. So I'm going to just simply put my 2 outside here. All right. Let's see. We're going to put outside here a coefficient of 2, 1, negative 13, and positive 6. So 2, 1, negative 13, and then positive 6. All right. So we bring this down, we get 2. Multiply, we get 4. Add this together, we get 5. Multiply, we get 10. Add together, we get negative 3. Multiply, we get negative 6, and then we get 0 here. So our equation would become 2x squared plus 5x minus 3, and a remainder of 0. We get more space. Right, so I have this here now, so I can say that q of x, it's similar to write q of x as x minus 2 into 2x squared plus 5x minus 3. Now, there's 2 ways I can go about this. I can just use simple factorization to factorize this, or I can do another synthetic division on this because I know the other factor as negative 3, all right? Now, I can say, well, I can find an x factor, but once you usually find one factor, you don't usually go back and look for the next factor. Right? As long as you identify one factor, that's all you need. And especially with something of degree 3, you just need one factor. So if I find one factor, that's great. If I find something here is degree 4, then I would need 2 factors. 2 factors would make it much easier for me. So now that I have degree 3, I just need one factor. So this is my one factor, and I just simply factorize the remaining part of it here. So I can factorize this, and I'm going to do this in yellow. right? I'm going to do this in yellow. So I'm going to say here 2x squared plus 5x minus 3. I'm going to say this is minus 6 when I multiply. I'm going to get 1 times 6, 2 times 3. And I'm going to see that if I have a negative 1 times a positive 6, I'll add them together, I'll get 5. Right? So I can say that this is 2x squared minus x plus 6x minus 3. Group back 2x minus 1. And then we have here positive 3 into 2x minus 1. So we have here 2x minus 1 and x plus 3. All right. Now, notice that I have this here, right? Because I could have done something similar to this. When x is equal to negative 3, and I think negative 3 is what we had up here, right? When x is equal to negative 3, then q of x, well, so q of negative 3 would be equal to, well, this here, simplified. So let me just copy and paste this. So let me just copy this here, paste this here, and I'm just simply removing the 2 and putting it with 3 instead of 2. Right? So I'm going to have here 3 here, negative 3 I should say, negative 3 and negative 3. Right? And that would mean 3 3s, 9 3s, 27, negative 27 by 2 is negative 54. And then positive 9, and then positive 39, and then positive 6. Right? So this here would be 45, and 45 and 9 would be 54, and then positive 54 minus 54 is going to be equal to 0. Right? Then we know for a fact, then, so we can say since q of minus 3 is equal to 0, then x plus 3 is a factor of q of x, right? And then that would mean if we use synthetic division, and I'm just going to take these to do synthetic division, the 2, the 1, the negative 30, nope, can't use that, sorry, wrong equation. If I use the 2, the 5, and the negative 3, that will work, right? Yeah, so let's see. I'm just going to do the synthetic division here. So this is negative 3, the 2, the 5, you just see that, the 2, the 5, and negative 3, and then here, so we bring this down, 2, multiply, we get negative 6, add together negative 1, multiply, we get 4, add together, we get 1. Oh, that's not making sense. We're supposed to get 0 at the end here. Let me double check that. So it is what? 2, 5, negative 3. 2, 5, negative 3. I have x plus 3 as a factor, so I'm looking at a is equal to negative 3. So let's check that again. 2, bring down here, multiply, we get negative 6. Yes, and then add this, we get negative 1. Multiply, we get not positive 4, but positive 3. Oh my god. Alright, so positive 3, and then we get here a 0. So then we get that the equation is 2x minus 1, and that's the other factor. So we can say that q of x, and I can just write this as the final answer here. Right? So I can just say, therefore, q of x is equal to, well, we have 2x minus 1, we have x plus 3, and we have x minus 2. Right? So those are all the factors. So what I prefer to do is I prefer to factorize. Once I reach this part here, I prefer to factorize rather than go and prove that this here is also a factor and then do the division to find out what the remaining factor is. That takes too long. So just simply find one factor, and once you find that one factor, then it becomes easier for you to do synthetic division and just solve the answer. So given that this is a factor of this, find the value of this. I don't think that's x. I'm supposed to find the value of a. Right? That was an error. Okay? You can't find the value of x because a is an unknown. Okay, so let's see. Given that this is a factor of this, we have to find the value of a. All right, so if x plus 1 is a factor of p of x, it implies that a is equal to negative 1 and p of negative 1 would be equal to 0. So p of negative 1 would be equivalent to 6 into negative 1 raised to the third power minus negative 1 to the second power plus a into negative 1 plus 2. I am supposed to put negative a. So this here is negative 6. This here would be positive with a negative sign here. That means that this here would be negative 1. This here would be negative a and then positive 2. So we're seeing negative 7 plus 2, which is negative 5. So we're going to have negative 5 minus a. And remember, this is equal to 0. So this here is equal to 0. And then that means here is equal to 0. So this is p of negative 1. And this is also p of negative 1. So we're going to see that if we add 5 to both sides, of this section here, we can see that we are getting negative a equal to 5. And then if we divide both sides by -1, we get that a is equal to -5. So therefore, a is equal to -5, and that's the answer. All right, so that is the last solution. This is the end of part 2 for the solutions. And from tomorrow, we will start with the next topic, which is something called completing the square. I should say next topic, which is quadratics. And the first lesson of that is called completing the square. All right, so I'll see you tomorrow. Enjoy the rest of your day.